This lesson is a continuation from section 1.4, surface area of a right pyramid. But in this lesson, our focus will be the surface area of a right cone. A right circular cone is a three-dimensional object that has a circular base and a curved surface. Similar to a right pyramid, a right cone consists of three components. First is the apex. The apex is a point where the curved surface meets. As we can see in the diagram, the apex is a point or the tip where the curved outer smooth surface meets. If we think of it as an ice cream cone, it would be the very tip or the bottom of the cone. Similar to the right pyramid, it has a height and a slant height. Again, it is very important to distinguish between the height and the slant height. The height is a perpendicular distance from the apex to the base. As can be seen from the diagram, it is the inside height from the tip down to the bottom of the base. A slant height is the shortest distance on the curved surface between the apex and a point on the circumference of the base. In easier terms, this will be similar to the pyramid, where the slant height was from the apex down the face of a triangle to the bottom of the triangular face. Here, it is the distance between from the apex down one side of the smooth surface to around the edge of the circumference of the distance of your circular base. Keeping in mind that the height is the inside height, or let's say inside altitude, and a slant height will be outside. In order to determine the surface area of a cone, we will need the slant height and not the height. Height is represented by H, slant height is represented by S. Now is a good time we can look at some objects that might be in our environment that could be represented by a right cone. Like I was already mentioned, an ice cream cone, or we can think of those white water fountain cups that you will see at the water cooler. Those are some examples that would consist of a right cone. The surface area of a right cone can be displayed by surface area equals pi r s plus pi r squared. Thinking back from grade 7 when you studied the two-dimensional shape of a circle, the surface area of a circle is pi r squared. Thinking back, diameter and radius, you have to be very careful between those two terms. Sometimes in a question, the diameter will be given and not the radius. Radius is 2 times the diameter, so if a question gives you a diameter of 8 centimeters, you will need to find the radius. The radius is half the diameter, so the radius would be 4 centimeters. The pi r s of your formula stands for the lateral area, which is the surface area of the object, not including the area of its base. So the lateral area is a smooth outside surface of the cone. In total, the surface area of the right cone can be found using surface area equals pi r s plus pi r squared. In this example, we can see how the surface area of a cone is calculated. Given the formula we just discussed, we will have to look at the diagram to determine if radius or diameter is given. As seen by the diagram, the radius of 6 centimeters is given. We do not need to half it this time because the radius is what we need. Now we have to check if we have the surface area, then we have to check if we have the slant height or the height. We do have the slant height, so we don't need to use Pythagorean theorem in this case to find the slant height. So if we go back to our formula, for our lateral area pi r s, it'll be pi times your radius of 6 centimeters times your slant height of 10 centimeters plus the surface area of the circular base. And the circular base is pi times your radius of 6 squared. Once you work out pi times 6 times 10, you will get 188.4. pi times 6 squared will give us 113.0. The sum will give us 301.4 centimeters squared. Later in a section, when you get to working out different types of problems involving the right cone or the right pyramid, you'll be faced with a problem where slant height will not be given, but the height will be given. So be very careful, keeping in mind you will need to use Pythagorean theorem to find slant height if height is given. In summary, for this section of a right cone, the surface area of the right cone is expressed by pi rs plus pi r squared. If slant height is not given, it can be found by using Pythagorean theorem. If slant height is given, the surface area formula can be used directly.